Also, one of the options we can do, it's called regenerative cycle, regenerative Rankine cycle. So we have Rankine cycle, we have reheat Rankine cycle, and now we have regenerative Rankine cycle. So again, this is how it looks like. So again, what you can see here, how many boilers we have? One. How many turbines? How many condensers? How many pumps? Two. So in the reheat cycle, we increase number of turbines, right? We have one pump, one boiler, one condenser, two turbines. In the regenerative cycle, everything's same except the pump. We have two pumps here. Pump number one, pump number two. Okay, so this is the main difference between them. And this is how the TS diagram will look like. So we have 1, 2. This one represent the first pump. Okay, because we have here, this is the inlet, so state number 1 is state number 2. Pump number 2 is state number 3, state number 4. So this is another pump. So this is pump 2. And this is here, pump 1. Okay, and then we have 4 to 5, this is the boiler. And then we have 5 to 6 and 7, this representing the turbine. And then we have the condenser. The inlet to the condenser is 7, outlet is 1. So this line represents the condenser. So if we see the idea of regenerative Rankine, so this one says for regeneration cycle, so what is happening? We have steam, we extract some steam from the turbine to heat the feed water. And what is the feed water? This is the water that exits the pump. So here in this one, or in this regenerative cycle, so what is happening? We have steam from the turbine, so we extract steam from the turbine, and we are using this steam, which as temperature is high, we are using it to heat what is called feed water. And feed water, this is the water that is exiting the pump, the water that goes to the boiler. Okay, the device or the unit in which we are have this interaction between the steam from the turbine and the feed water, this is called feed water heater or called regenerator. So we have feed water heater or we have regenerator. And this is the device or this is the unit we are using to exchange heat between the steam from the turbine and the feed water or the water exiting the pump. This feed water can be or have two ways. It can be open or direct contact feed water. So basically it will be a mixing chamber. We have direct mixing between these two streams. Direct mixing between the steam and the feed water, the water that exiting the pump. Or closed feed water, something like heat exchanger, like shell and tube heat exchanger, for example. Let's say we have some tubes and we have fluid going inside the tubes. We have another fluid outside the tubes. This means we have indirect contact. This is no direct mixing. The streams, each stream will not be directly mixed with the other one, but they can exchange heat. So let's see the difference between them. Here we have open feed water heater. How I know if I look to the diagram, this is open feed water heater. See how many inputs, how many outputs you have. Here, how many inputs I have? 2, right? And how many output I have? 1. So this means the 2 inputs mix it together and I have a single output. For the closed feed water heater, for this one, this is closed feed water heater. So why this is closed? Because how many inlets I have? This is the first inlet, this is the second inlet. How many inlets? 2. And how many outlets I have? So this is something similar to heat exchanger. We have 2 inlets, 2 outlets. They will not be mixed. Okay? Similar to we have like tubes. One fluid moving inside the tube, other fluid moving outside the tubes. They are not directly mixing, only they are exchanging energy. They are exchanging heat transfer. Okay? But they are not mixed together. So this is the difference we have. So again, from the figure, count how many inlets, how many outlets. 2 inlets, 2 outlets, this is closed feed water heater. 2 inlets, 1 outlet, this is open feed water heater. So we have this boiler. So this is the first component. This is your hot reservoir. So the boiler, you have the outlet of the boiler, will go to the turbine. So usually in the Rankine cycle, we have 1 outlet from the turbine. But what we have here, we have 2 outlets from the turbine. 1 outlet will go to the condenser, which is the conventional way that you have. The outlet of the turbine will go to the condenser. But here we have part of the turbine outlet will go to the feed water heater. And in this feed water heater, what is happening? So the part that goes to the condenser will go to the pump, and the outlet of this pump will go to the feed water heater, and here we have mixing will happen. So here in this feed water heater, we have mixing between the steam from turbine and the pump number 1 outlet. So the turbine, the outlet of this turbine is divided into 2 streams. Stream number 1 will go to the feed water heater. Part number 2 will go to the condenser, will go to the pump, and then after the pump it will go to the feed water heater. So the 2 streams that coming out of the turbine will be mixed at the end. But one of them directly will go to the feed water heater, one of them will have the conventional path that it should have. It go to the condenser, after the condenser it will be pumped, and after pumped, instead of going to the boiler, it will go to the open feed water heater. So we have heat transfer will happen inside this feed water heater. And then the outlet of the feed water heater, so we are mixing these 2 streams together, combine them in one stream at higher temperature, and the outlet of this stream will go to another pump to increase the pressure to the pressure that we need it at the boiler, and we will introduce it again at the boiler. So what is the difference between this one and the other 2 ones? So Rankine cycle, the regular Rankine cycle, we have boiler, we have turbine, we have condenser, we have pump, and that's it. Reheat cycle, we have boiler, we have 2 turbines, we have condenser, we have pump. So in the reheat cycle, we have 2 turbines. Okay. In the regenerative cycle, we have boiler, we have 1 turbine, we have 1 condenser, we have 2 pumps, and we have another unit added. It's called feed water heater or generator. If we want to see the TS diagram for this one, so again, so let's start with the first one, the boiler. So the inlet to the boiler is point number 4. So this is point number 4. This one is the inlet to the boiler. So the boiler will increase the temperature, will change the phase at constant pressure. So, and the outlet will be at point number 5. So point number 5, this is the boiler outlet. And at the same time, this is the turbine inlet. This path from point 4 to point 5, this path is isobaric. So which means that pressure at point 4 equal pressure at point 5, because this path again is isobaric. Then what is happening that at point 5, this will go to the turbine, and we have part of this will exit as point number 6. So this is point number 6. So this is outlet 1 from turbine, and this one will go to the open feed water heater, and we have the other stream that will exit the turbine, will exit at point number 7, outlet 2 from turbine. We have 2 outlets from the turbine. So one at the condition that represented by point 6, another one at point 7. So point 7 will go to the pump, so we will go to the condenser. So this is condenser inlet. So we have condensation will happen until we reach point number 1. So point number 1, this is the condenser out, or pump 1 inlet. Then 1 will go to 2. So point number 2, this is pump 1 out. Then what is happening? Point 2 will go to the feed water heater in order to mix it with point number 6. So point number 6, this one is the inlet to feed water heater. Point number 2, this is also considered an inlet to feed water heater. So these two streams will be mixed together and the result will be point number 3. So this is point number 3. This is the outlet of the feed water heater, which is inlet to pump 2. So 6 and 2 mixed together gives point 3. Mixed solution at conditions at point number 3. Point number 3 will go to pump number 2 in order to give you 4. So 4, this is pump number 2 outlet. And at the same time, this is the inlet to the boiler, and cycle will continue this way. Clear? Any questions? Any questions in this part? Okay, so similar to what we did in all of the cycles, we have some energy analysis we can do to this one. So again, the objective is to find the efficiency, and the thermal efficiency is 1 minus Q out over Q in, or the network obtained over Q in. And how can we find the network output? How can we find the Q in? How can we find the Q out? So you need to find enthalpy. So the objective is to find enthalpy at all these points. And here we have some difference in the relations. So especially at Q out. Because let's say Q in, this is H5 minus H4. Still have one step boiler. The boiler inlet is 0.4. The boiler outlet is 0.5. So the difference in the enthalpy between these 2 points will give you the amount of heat added to the boiler. But in the condenser, so what we have in the condenser we have H7 minus H1. So this is delta H of we have in the condenser. But here we have one like minor changes happening, because not all the fluid that goes to the turbine will go to the condenser. As you can see here, we have the turbine, we have one inlet to this turbine, but we have 2 outlets. Only one outlet of these 2 outlets will go to the condenser. So not all the amount of the working fluid will go to the condenser. So this is why here we multiply with 1 minus y. And what is minus y? 1 minus y, this is the fraction of the working fluid that goes to the condenser. Okay, so if you can see here, this turbine, if we assume this amount of turbine is 1 kilogram per second, for example. So here we have y. Part of this 1 kilogram per second will go to the feed water heater. 1 minus y, the remaining part of this inlet will go to the condenser. So we have the amount of the turbine inlet that will go to the condenser is 1 minus y. Not all the amount of the turbine will go to the condenser. So this is why here we multiply with 1 minus y. For the turbine here, the turbine outlets, and the pump inlet is also, we have some changes happen, because the turbine we have like expansion on 2 stages. If you need to find the amount of work output from the turbine, so it will be H5 minus H6. So the difference in this enthalpy, all the amount that goes inside the turbine, its enthalpy will be reduced from 0.5 to 0.6. Then we have part of the fluid inside the turbine will go to the feed water heater, and its amount is y. And what is remaining is 1 minus y. This only will continue the expansion from 0.6 to 0.7. So this is why we have H5 minus H6. All the working fluid inside the turbine enthalpy will be decreased from 5 to 6. Then only 1 minus y. This one will continue the expansion from 0.6 to 7. Because we have a certain fraction y, this one will be removed from the turbine and goes to the feed water heater. So this is why we have the turbine is expressed by this way. The inlet to the pump, or the amount of work added to the working fluid to the pump, so we have 2 parts here. The first one, we have pump number 1, we have pump number 2. Pump number 2, all the fluid will go to pump number 2. But for pump number 1, only we have 1 minus y of the working fluid will go to this pump. So the thing that you should consider here, when you are analyzing any equipment, do you have all the amount of working fluids introduced or exist in this equipment, or only part of it? Is this part y or y minus y? Is it clear? Any questions? And here, how can we find y? Y, this is the mass flow rate at point number 6 divided by mass flow rate at point number 5, or enthalpies. You can find this equation by energy balance. And similarly, the work of the fluid is V delta P we have here, similar to what we did in previous cycles. So again, all these equations will be given, so there is need to memorize them, but at least you need to know that the logic behind, so why we multiply with minus 1 minus y in some of the terms we have. So this is based on what is the amount of the working fluid that exists or subjected to the change that is happening in this process. So again, the whole idea, the equations are the same. The same equation you will use to calculate thermal efficiency. But if you have Rankine cycle, you have equations to calculate Q in, Q out network. Ideal reheat, different equations. Regenerative Rankine cycle, we have different equations for them. Any questions? So next lecture we will have examples on these two cycles. Okay, thank you.